Solve the inequality. All right, so we're looking at example A here, and it says 2x cubed plus 5x squared minus 12x is less than 0. So remember, we want to set it equal to 0 and try to solve for the 0. So we'll have 2x cubed plus 5x squared minus 12x is equal to 0. Then try to solve by factoring. So it looks like we can take an x out of here, right? So we'll have 2x squared plus 5x minus 12 is equal to 0. At that point, we have a trinomial that can be factored times x, right? So let's leave the x out here, and let's try to factor this trinomial. We're looking for basically a way to split up the two terms in the front and the back. So let's do 2x and x. That'll give us the 2x squared when we multiply. And then we're looking at 12 and thinking about factors of it. So remember, we don't want to do something like 2 and 6 because we can't have common factors, and 2 and 6 would both have a common factor of 2 here. So let's try something like 3 and 4, and I'll be forced to try the 3 and 4 in this order because I don't want to put the 4 with the 2 because that would give us a common factor, right? So 3 times x would give you 3x, and then that would give you 8x. And do they indeed subtract to give you 5x? They certainly do, but the problem is right now we would end up having what? Negative 5x. So we need to make sure that when we put the sign of each, we make sure that the product ends up being positive. So we're going to make the 4 positive and the 3 negative. That way we get negative 3x, but rather a positive 8x, so that the difference is actually a positive 5x. All right, so we've got the factoring done. And with the factoring finished, we're going to take those pieces separately and set them equal to 0 using the zero factor property, which says if you have things that are multiplied and the result is 0, then one of the things must be 0, or all of them, right? Okay, so x equals 0 is already solved. That's one little 0, right? If we try this one, we'll end up getting 2x is equal to 3, and then we'll divide everything by 2. And we'll end up with the idea that x is equal to 3 halves. And then finally, x will be equal to negative 4 if we solve that one there. All right, so we end up with 3 zeros. So let's put them on the number line. So working left to right, I will have negative 4, then 0, and then 3 halves, which is basically 1.5, right? Okay, from here we want to test regions, right? So on this side, I'm going to test negative 5, right? Between these two, I might test negative 1. Then after that, I might test 1. And then after 3 halves, I might test 2, right? Positive 2 is nice and easy. All right, so we're going to test these numbers into the factored version of the equation. In other words, we're going to test them in here. The reason why I'm testing them in here is because it's just simpler to do that. Really, though, if you're by yourself doing this, you might want to put it back into the original equation, because if you screwed up in the factoring in some way, obviously, you wouldn't be able to catch your error if you're using that version of the equation. So I don't know. I mean, I guess it depends on how confident you are in your own work in the factoring step. On the other hand, if you messed up the factoring step, chances are you'd still get it wrong because you wouldn't have the right zeros for the function. So I think it's safe enough to check it in the factored form of the equation. So let's go ahead and do that. So what I'm going to do is go ahead and plug in the negative 5. So it'll be negative 5 times 2 times negative 5 minus 3 times negative 5 plus 4, and we're asking basically if that's less than 0, right? So remember, the original inequality is less than 0. Okay, so we end up with something here that's negative. I'm just going to do some quick arithmetic here and show that this is negative. In other words, I'm just going to do the signs, right? These are all negative, aren't they? If you look at this, right? The one there on the left is negative. 2 times negative 5 is negative 10, plus negative 3 is negative 13, and then we have negative 1. Well, I guess I'll just write in the numbers, right? Negative 5, negative 13, and negative 1. And of course, the result then, of course, is 3 negatives multiplied, which is indeed less than 0, because 3 negatives multiplied make a negative number, and negative numbers are less than 0. So we're going to say that this area is part of the solution. So I'm going to shade this area, and then I'm going to use a rounded parenthesis here, because I want to show that we don't want to include negative 4, because negative 4 actually makes the inequality equal to 0, not less than 0. Okay, let's test negative 1 now. Let's test negative 1. We do the same thing. It'll be negative 1 times 2 times negative 1 minus 3 times negative 1 plus 4. All right, so again, just use the signs here. So this will be negative. This one's going to be negative because it'll be negative 2 minus 3. So let's actually put the numbers. I keep saying I'm only going to do the signs, and then I'm doing the numbers, right? So negative 2 minus 3 is negative 5, and then positive 3. Now, a negative times a negative makes a positive, and a positive number times 3 is going to be positive, so it ends up being a positive. That number, of course, is greater than 0 then, not less than 0. So this is false. So we're going to say, hey, that's false. We can't use that area. Let's test the other one then. Let's test positive 1 now. So to test positive 1, I'm actually just going to get rid of the negative signs here, right? So I'll make this. So it'll be 1 times 2 times 1 is 2 minus 3 is negative 1, right? And then times 5. Well, that's basically what? Negative 1 times 5 or negative 5, and that is less than 0. So that checks, right? That's good. So we're going to say that this part is also a solution. And again, we want to use that kind of rounded bracket idea or rounded parenthesis. Now before we close this last one off, let's go ahead and check 2, because maybe 2 also works. And if it does, then we might have to change that last parenthesis. But let's test to find out for sure. So let's plug in 2. So we'll have 2 times 2 times 2 minus 3. And then we'll have 2 plus 4. Again, plugging it into the factored form of the equation. So we'll have 2 times, this will be 4 minus 3, which is just 1, right? And then we'll have times 6. Well, that's essentially 12. And 12 is not less than 0. So that's not correct. So this part is false, and it was okay to round off that parenthesis at 3/2 because we did not want to include 3/2, and there are no solutions beyond that. So our answer basically goes from negative infinity up to negative 4, and then goes from 0 to 1.5. So let's write out our solution that way. So from negative infinity up to negative 4, round parenthesis at negative 4, always round the infinity, union, starting up at 0 again and going up to 3/2, rounding off 3/2, and that's our solution. So it's a union of those two sets, or those two pieces of the number line. All right, let's tackle example B then. For example B, we want to first set it equal to 0. So we'll have x cubed. If we bring the negative 8 over to the other side, it becomes positive 8, and that's less than 0. Then from here, we have to factor this. This is a special factoring form. It's the sum of two cubes. So we're going to start by taking the root of the first thing. So x cubed, the root of that is x, right? In other words, what did you cube to get x cubed? You cubed x, so we put x there. We keep the same sign we had originally. And then what did you cube to get 8? Well, you cubed the number 2, right? So we'll put 2 there. Then you open up a trinomial. We're going to set this equal to 0, remember, because we're going to change the inequality to an equality for the purpose of solving for the zeros. And then what we do to finish the pattern is we square that term we put here in front. We square the term we put here in the back. And then for the middle term, it's always the opposite sign we had here. So it'll be negative, right? And then, oh, by the way, the sign for that, since you squared it, will be positive always. But going back to this, the sign here, you take the opposite sign, and then you do the product of the two terms, so 2x, right? And that will give you the factoring for the middle part, right? Then from there, you have two things multiplied that equal to 0, so we're going to go ahead and separate them and set them equal to 0 separately. And then this one is very easy. You get x is equal to negative 2. This guy actually is always prime. It's not factorable. And not only that, it doesn't have any real zeros. And the reason why it doesn't have real zeros is actually because if you check the discriminant for the function, you'll see that it ends up giving you something negative. You remember the discriminant from the quadratic formula? That's the part under the square root, right? We would take b squared. Well, the square of negative 2 would be 4. And then it's 4a, which is 1, times c, right? And you can see here that this part is going to be 16, so 4 minus 16 is negative 12. If this piece is negative, then we don't have a real 0. So we're going to say that that doesn't have to be solved for us. We're not going to find any real zeros here. So let's ignore this piece. We can't get anything from that. So we really just have one 0 to consider, and that's negative 2. And then because of that, we can just put a simple negative 2 there. So we're going to end up testing numbers on either side of negative 2. For example, I might test here simply negative 3. And on the other side, I might test just 0 because it's nice and simple, right? Let's test negative 3 first. If I put negative 3 into x cubed, is that less than negative 8? Well, let's see. Negative 3 cubed would end up being negative, and 3 to the third power ends up being 27 because it's 3 times 3, which is 9, and 9 times 3, which is 27. Is that less than negative 8? It is less than negative 8, right? So that checks. That means this part is a solution to our equation. Again, we're going to use a rounded parenthesis because we don't want to include negative 2 because negative 2 gives us 0, not a number that is less than 0, right? Now, if we test 0, we'll see what happens there. Well, if I plug in 0, I'd have 0, right? Is that less than negative 8, right? Why did I say 0? Because it'd be 0 cubed, right? And 0 cubed, of course, is 0. Is that less than negative 8? That's false, right? That isn't true. 0 is not less than negative 8. Negative numbers are less than 0. So our answer is basically the part that we have shaded on our number line. So from here, all we have to do is go ahead and say our answer goes from negative infinity, right, all the way up to negative 2. And we use a rounded parenthesis for both. And this little set is the set of solutions for that inequality.